Well, hey everybody, Rob Dominic here, MLTI ambassador. I'm going to be talking today about using digital tools to uncover student thinking, specifically in math class. Prior to this position, I was teaching math, middle school math at Brewer Community School, and even before that, I've done middle school math in other districts as well as high school math. So I'm going to share some of my top tools and strategies to be able to use math digitally in the classroom, whether you're in person or remote or hybrid, whatever it may be. Um, and kind of focus on the strategies that go along with the tool integration itself. That's just as important. All right, so let's first kind of talk about the benefits of each here. You've got the in-person learning, which is almost irreplaceable. I mean, you can still have quality online remote learning for sure, but there are certain aspects that just in person just makes great, right? You're reading the students' faces, you're circulating a check on progress. You can find misunderstandings and address it right there in the moment. And then especially for math, right, they can write out their work, which is the mantra that's repeated in math classes, it seems. At least it was for me, where you're asking them again and again and again, hey, show your work, show your thinking, show your proof, explain to me, things like that. So obviously that's the big part of it, and that's what the in-person offers, right? But then you do have some benefits of the digital. There is some rewarding aspects of the digital piece of it, where you can have them save and organize their work, so there's no more losing it. You can have them track progress automatically, and then also have them revisit resources as needed. And then also it gives that ability to have immediate feedback depending what program you're using. So they're not waiting on you to circulate and help 20 other students in the classroom all at once, right? It does help alleviate some of that workload. So, obviously the catalyst for all this was the pandemic and the switch to online learning and the havoc that it caused all over. But I feel like, after the initial shock of everything, some better routines were established. People got a little bit more comfortable and familiar with the digital world. Again, it still wasn't replacing the in-person, but I feel like those skills became more commonplace for everybody. So the question is now, how can we take those skills and not just ignore them, not just pretend like it never happened, but how can we take those skills, blend it with the in-person benefits, and try to hit that sweet spot right in the middle? So then that way you're doing work with students in the classroom. You can still have digital work or digital assignments become an integrated part of your classroom, and it's not just this segregated activities where you've got in-person only, paper only, digital only. How can we blend it all together? So, for good or bad, the pandemic definitely shook up this educational model and the possibilities that come from it. Sometimes that's what we need. So the biggest shift I think that came from that is that, and I think this has kind of been an underlying piece for math for a little bit now, is that math is usually seen as a performance subject more than a learning subject. This quote comes from Naomi Church, math specialist that I heard on the Easy Ed Tech podcast with Monica Burns. And that part of it is very true. And I think that's become part of the shift that's been happening lately, is trying to move it more towards a learning subject than just right or wrong, perform. How did you get that? Follow these procedures, follow these steps, these rules, and kind of give the kids a chance to explore and learn and show the process and dig into their thinking more. So because that's been a shift overall in the math curriculum, the math education, I think that we can use that goal or that shift to really make digital tools effective. Because if you leave it as just asking students to be right or wrong only and to solve problems, and hey, do 25 to 30 IXL problems and that's your homework, it's not going to be as effective. So we have to incorporate this the shift in math education, as well as the shift in the digital and in-person learning that happened. And I think that overall that it's a good shift because you're going to be able to build student confidence and hopefully lower their math anxiety that is quite common now for students by the time they reach middle school. I know I see it once they get to me in middle school levels, and in talking with some math specialists around, they see it kind of start to shift around third or fourth grade. Students start to feel that anxiety or that disdain for math. So if we combine all this together, if we combine the digital world and then this shift in math education, you can make some effective online learning. So again, the shift going more of a conceptual understanding of math, having students understand the why behind things, having them explain their process and the why instead of just, did you get it right? Did you get it wrong? Focusing on that piece of it, more of a learning subject versus the performance subject. And then if we can hit that sweet spot with those two shifts, the digital and the shift in focus on the curriculum, we can leverage the technology in a much more effective way overall. And I feel like you as the teacher as well as the student can get more out of it, and you can be better informed about your students' learning, and hopefully they can have some more confidence in their math learning. So let's talk about some of the tools then that can be offered or can be used to help with this sweet spot and can help draw out the student thinking and understanding of the content. And as I go over these, hopefully, it at least gets the wheels turning. Maybe you're familiar with these tools, but maybe at least inspires or gets the wheels turning about some other possibilities that you could do with it all. That's great too, because that's just how you build upon all of this, right? This isn't the end all be all. These are just the three big things, the three top resources that I use to undercover student thinking. So hopefully it benefits you and you can take it from there. First one on here, Google Slides. I use that most often, be able to have students use them as notes and then activities for lessons. So that way it makes it more interactive for them. So they are more engaged with their learning instead of just a passive piece of it. And then same goes for Desmos, where they actually do activities and have questions that are geared towards them answering and explaining their thoughts. And then Pear Deck is used in a similar way as Desmos, but the abilities that it presents because of the way it's set up and the way it's programmed, you can do a few different things with it than you can with Desmos. So those are the three that we're going to talk about, and that's how we can transform, student learning online with these pieces. So Google Slides here. Okay, I'm not going to go into a formal tutorial about how to do all of this because that's a whole separate piece. But for right now, the whole idea is just that it can be done, that it's possible, and you can dig into it yourself, or you can, ask about it. Feel free to reach out, and we can cover that as well. So the big idea behind this, any notes that I made or any activity that I made for the students was using the edit theme option on Google Slides. And this made it so I could paint on or paste on certain parts of the slide that students couldn't move, and then it would make other parts interactive that they could move. I'll give you an example of that here with notes that I made for their unit on mean absolute deviation, which was a harder concept, but by making these interactive notes, it got them to understand a little bit more and at least got their minds on as we were going over it instead of just passively saying that they were writing things down. So here we are with starting, with box and whisker as well. Start box and whisker plots, and with these notes, right? It's pretty simple here. I can't move this, right? And I'm viewing this as a student right now because I have a different account that's the owner of this, and I'll show you that in a minute. So I'm a student right now. I can't move this piece of it. This box and whisker is set up. I can, however, my other account, I guess I have to, because I didn't share it with this. I see. Hold on one second. Boom. We'll put it into here. So here we go again. Sorry for that. I forgot I had not shared it as a complete student. I was just seeing it as a viewer only. So on here now, same deal. Even as the owner right now, I cannot move this piece. I can move this. Again, so this is what the students would be able to do if they were shared and they had edit rights. That's why the other account had viewing rights only. Here they have edit rights. So they can edit these pieces that are movable. But even though they have edit rights, they can't change this right here, the box and whisker. So they can diagram a box and whisker plot using that. Down here, same deal. They can't move this number line, but as it says, we would have made some numbers in class, and they would have to use that as a median and change their IQR, stretch it out to whatever it may be, and they can diagram the numbers that we gathered in class live. So we are taking that instruction. It's not like they're just doing this on their own. They're taking the instruction in class and combining it with these notes at the same time. All right, so same thing here, right? They have a box and whisker, but here they have to click and they can add the text. Now this is editable. So since they have to click on here and edit and type in there, they can end up deleting it, because that box is completely editable, but that's a simple thing to be able to get back. Whereas this other piece, they can't manipulate. Then, mean absolute deviation, which is a process for sure for them at times. Again, I've got here that they can't move, and then these activities for them to type in and answer. Here, explaining more about the concept of what mean absolute deviation tells them instead of just having them answer questions and practice on it, trying to get them draw out what the meaning of it is, interpret what's going on. Why is widespread data potentially good in research studies? How is this related to the bigger cause? How does it extend elsewhere? With resources like photomath out there, or even just camera phones right now as it is, sometimes they're robust enough where they can scan the problem with either the app or their just regular camera, and they can come up with the answer, right? It'll search for them the answer of how to solve it and even give them a step-by-step. So if you want them to show their work, they can show their work because the app shows it to them. Does not mean they actually did it. But apps aren't going to explain the questions and the concepts that you ask them separately. And if they do have to look it up, you know what? They're looking up the words to it, and maybe as they're explaining themselves and explaining, they have to interpret what they read online and then explain it in their own words, or at least write those down themselves. So hopefully those words are being processed better for them. Whereas, if they're just writing down numbers, there's no conceptual piece, instilling in their brain at that time. All right. So again, to do this, since I am in edit mode, and you can do this with any slide, you go to slide and you go to edit theme at this point. I'm going to this one to kind of show things a little bit more, right? I can't move the number lines, but if I go to slide and edit theme, now it's kind of like the behind the scenes part of it. So all of this I can edit just like any normal slide. I can add shapes and images, lines, whatever I want, and color it, whatever. I can add it. I can add to it just like any piece. But all of these images or all of these diagrams that I put on here will not be able to be moved unless you come to this edit theme option. If I want them to be able to type in a box, a text box, which is what this blue is a normal piece, and again, that will be treated like an image, so you can't touch it. But placeholders, right? Body text placeholders is where they can type. So if I go back now, there's this box right here that I just put on there that they can actually type in. However, the annoying part is, right, when you put the box in, you can't put instructions in the box itself. You have to put instructions next to it or near it. And when you put it on here, it looks messy because they've got all these different bullet points to it, but it doesn't show up when you actually go to the real slide, right? I'm gonna get rid of this because it was too messy. Right down here, it's got all these bullet points, but you go to the real slide, it's got just that. That's it. So that's the short of it of how that's done. There's a little bit more you can do with it, but that's the overall idea about it. You can make it so they interact with your notes and what's going on. I like this a lot more. Instead of students getting the guided notes from the book or the curriculum that they just kind of fill in the blank or whatever, or you have to use the examples that are in that book in order to have it make sense to them. You have to make sure that you're following along that way. Whereas these ones, I can kind of make them what I want them to be. The students it gives them a chance to engage with all of it. They have to explain themselves. It's, to me, more engaging and minds on than just having students fill in the guided notes that the curriculum might provide, because they might just copy from somebody else. They look at their friend, hey, what was that word? I didn't remember what it was. They get the word, they write it down, and that's it. And it's done. They can show that. That's it. Whereas here, again, it causes them to engage more with the material and have it subtly set in, if not consciously set in. All right. The other piece here, going back to this similar piece, is an integer activity. We'll take it over here. So here again, I made an integer manipulative. We were learning integers, and I wanted them to be able to explain how they solved problems with positive and negative numbers. Everything that I found online was a little bit too complicated, or not exactly framed or set up how I would like, or not simple enough. There was just too much going on. I was like, you know what? I don't need anything crazy. I just want to do a simple activity with them. I can make it myself on Google Slides. So yet again, using that skill of edit slide, this is not editable. This workspace is not editable, right? The only thing that they can is the problem that I would either type in or they would type in, and then the answer to it. And also these chips, these pieces here, right? They can drag in here over and over again. So if the problem up here was like, -3 plus 2, they could have it on here. And then using the power of Screencastify, Flipgrid, iMovie, the screen recording on iPad, whatever your device is, screen recording somehow, they would record themselves explaining out how they solved this, right? So they could talk, all right, here's the 0 ordered pairs, right? If they cancel out, I'm left with a -1, and they type it in. Or they they have a different strategy or whatever, and they say, well, there's more negatives than positives, so my answer is going to be negative, and there's one more, so they can explain that. Whatever their method is, they have a chance to do it here. And the way I did this, to make it look like there's a whole bunch of them here, and again, there's not. There is a finite amount, even though it goes on and on and on. There are a lot in there. Right, because of all that, right, it looks like it's an infinite pile like it would be online. It's not. I just think I did a duplicate. I would click on one of them and boom, 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 Control D, duplicate a whole bunch of them. And then once I have them all, I go to Arrange, Align in the center, and then Align in the middle. And now it looks like a stack. And then to move them all, I have to, again, select like this, because if I just select one at a time, I don't move the whole pile. To do everything, I have to go like that. So anyways, it makes it look like it's like a real activity online. And then I especially like combining this with Flipgrid, because Flipgrid, you can set the time limit. I know the free version of Screencastify is, about 5 minutes. But if you're 5 minutes for 80 to 100 students, that's a lot of time. And you can kind of skip through when it's there, but you can limit the time better on Flipgrid or something like that instead. But it's up to you how you work with that. Again, we're not diving deep into that. We're diving into how to have students explain their thinking. All right, so again, this gives me a better idea of their thinking rather than just having them solve a whole bunch of positive and negative problems. I want to know, how are they attacking it? Is their thinking on the right track? All of that. Okay. Next piece. Desmos. Okay. Desmos, if you haven't explored it, is a great activity and interactive piece for math. It started off as that graphing calculator, of course, but it's evolved into even more at this point. You can go to the Desmos website, but to get teacher account, each time you can log in to teacher.desmos.com. That's where you would be able to have your dashboard and everything saved there. So what I like about it is it's got dynamic activities that help the students visualize. It has a teacher dashboard, so you can see their work along the way, and you can leave feedback for them, right? So you can dig into their thinking and react to their thinking and give them comments about it back, instead of just the next day they come to class, right or wrong, that's it. And that's where their annoyance with math comes from. Of course it is. If somebody's doing something poorly on my team that I coach, and I'm not telling them why or how to fix it, or they're just repeatedly getting things wrong without any talk about the process, it's going to be discouraging. So a couple activities to point out that really highlight these full features of it that I like is this gym membership and pool boarder. And I'm going to go over here to do it. So this is the Desmos login, right? They actually do have their own curriculum that they've started. And Desmos is nice, if nothing else. It gives them a visual about everything, right? So that helps those more visual learners. That problem with math, again, sometimes is that they have to try to learn things conceptually or just with numbers on their paper. They don't have a graph that they can interact with or images or anything like that in front of them that they can help associate with this learning. They just have to try to associate the numbers and the way it looks, and that doesn't help, right? That's boring. So it's a Desmos activity of gym membership that I like a lot, that I do each year. We'll go to this one that has examples already. So this is what the teacher dashboard would look like. Okay. These would be all the students. Now, these are not their real names. You do have an anonymized button that you can have at any point. So when you're displaying student work, you can anonymize, and they are given a famous mathematician's name that is their pseudonym here, and you can see their account if you want to afterwards, but when things are displayed, you can leave it like that and nobody has to know. Although, in my experience, again, students just like to shout out who they are, so the anonymity is almost non-existent, but it's still there as a good option. So in this activity, students have to, I'll show you. They have to take a situation where somebody's joining a gym. Mateo is his name. Joining a gym, they have to decide on the membership that works best and why, and explain themselves. This first slide asks them to just overall, what would be some things to consider for this character Mateo to think about in order to choose a gym. So immediately, without any information, without having to really dig into anything mathematical, they're getting their minds on and engaging with the material because they're just asked for their own opinion. What would you do in this situation? And there's no prerequisite for any sort of math yet. That really helps engage them. Then gym membership. All right, so now they actually have some things to consider. Again, just describe the differences you see among the plans. Tell me what's going on. What do you notice? Not solving anything yet. Then they have to, to consider what would they want to ask Mateo to help decide what's best for him. They end up graphing them, right? So, I mean, if this is a graphing unit that this is used in, and they have to graph them, but this is the fourth slide, right? We're halfway in, and they're just graphing now, and there's still more to do afterwards. The graphing is almost just a one piece of it along the way. And afterwards, after they have the graphs, they have to make a decision on what they would choose. And right, again, this is the real math piece. This is the real math application, because the math can be solved by a phone, but the corresponding response or the decisions or the analyzing afterwards usually isn't. So this gives them the students a chance to explain themselves. And then, is the cheaper always better? Right, and then they do create their own afterwards. So they get some more playing around with the graphing a line. So all great stuff, right? That's the activity anyways. But from the teacher side of things, which is great, right? You can see their responses here all at once if you want to, like this. You scroll through. I can see their responses here to this question, right? All of them in one spot, and I can display this. I can project this on the board if I want to. All the way through, same deal. You can see all the responses. You can highlight certain ones. So again, if I click on like this answer and this answer, I can say, oh, save these as a snapshot. And if I save them as a snapshot, they appear here. So when I display answers on the board, and I don't want to display them all because I want to eliminate some that may not be relevant, I can put that here. And then another question, I can say, here's the ones that I highlighted from that one. So that's a nice handy feature. I do wish they could just hide, that you could just hide certain ones. So like, let's say I wanted to present all of these, but one of them was one I did not want to put on the board. I don't think there's an option but to click and just say hide one versus having to click all the other ones and say highlight those. So anyways, you can do that. And then if you click on a student here, you can then respond to them. You can give them a comment about it. So here I already have some already. As an example with the first one, this student wrote something and I say, just a quick thing, nice ideas, whatever, just to demo this. And this is what they would see as well. And they would see this kind of highlighted green comment section, a comment button right here that they would know they have one. And then they can click and go to the screen that I wrote the comment on, right? And they can then, I can edit, but they can then click the hey that they've seen it, right? It shows me that they have not read it yet. They can go in and say that they've seen it, and I know that they've seen my comment to them. So as a teacher, you can give feedback that way, and then I can continue to click through this student's work. I can go to each slide and go through that student. There's their graphs that they made. Or I can leave more feedback each time. Or I can go and say, all right, I want to see everybody's answer for this question. I can just scroll this way, and it will show me all of their answers for this slide 5 here. So I can go either way. I can go by question or I can go by student, which is pretty handy. And then, again, you can make comments at any slide to any student by this way. So you can kind of establish your own comment bank by copying one response that's going to happen often and then paste it in, whatever it may be. Okay. So those are the helpful features of Desmos. And again, things that I like about it that elicit those thoughts that the student has about a topic. And again, a lot of it goes with the strategies that are used in math class. And I think that's the way it should be. No tool is going to be the silver bullet for all of math or all of education. It's how you use the tool. That's why teachers are going to be necessary forever, because you need to be able to use these tools effectively in the classroom, how you structure things. So using those questions, Desmos becomes even more effective, and using that mindset, it becomes effective as well. A couple quick things. You can, again, you can limit the pacing on here. So if I only want them to work on one slide and to kind of follow as I go, I can do that. Or if I say, all right, you can use the first 3 slides at once, and then they can't go any further because it's a stopping point and I want to stop them and discuss everything, I can do that. So that's nice. And then, of course, pause their screen, which will kind of lock their website. Not their whole screen, but just the Desmos activity that they're on. Okay. So that's the Desmos. Again, the positives of that, and how it's used with the questions that elicit student thinking versus just solving the problem. Next part, Pear Deck. The last piece here, in a similar fashion that was used. You're trying to draw out students' thinking, except for Pear Deck just has a little bit different way of interacting with the material. For the premium version of Pear Deck, which, out of all the tools out there, I think premium version of Pear Deck is worth it. There are some really good ed tech tools out there, and not all of them are completely free. Some of them are, which is great. Pear Deck isn't, but I do think it's worth the full features, because without it, you can have them make text, multiple choice, and number slides, but with it, you get the draw and draggable, which make things a little bit more interactive and dynamic, which I'll show you in a minute. Pear Deck works with Google Slides or Microsoft PowerPoint, so it works with the skills you might already know from Google Slides, which is nice. Makes it very quick and easy to adapt. It has a dashboard. Again, that's part of the premium feature, but it has a dashboard that's similar to Desmos that you saw. You can highlight student work just like we did before, and then you can also leave them feedback. And I'll show you through all that in a quick demo here. Again, if you want anything deeper or further, let me know and we can dig into that as well. Feel free. So this is a presentation. Over here that I have. So it's this one right here. I have it set up for, again, math class, just to show you some features on here. This is how students would get on here, joinpd.com. They would go to that website, and then they would enter in this code. It's as simple as that. And this one's not loading with that link, so I'll just do just that. I'll pretend this is the student. This is what they would see, joinpd.com, and YTA RFN code, so they would type that in, and then they get in, and they are seeing now the presentation. That's what this is. I have control over it right now. You can make it student center, so if you want an assignment that students do at their own pace, you can turn on student paced here, and they can just go through it at their own leisure, at home as an assignment or in class, and you're just circulating and they're doing it at their own pace. You cannot limit it to certain slides you can in Desmos, but it still has a similar idea where it's either teacher-led or student-led. So if I go through, I'm the teacher here right now presenting all this. So this is also a kind of a tutorial about the features of Desmos. It's of Pear Deck. It's not just a math lesson. So that's why it's got all of this. But I click next, and the student sees it. So this is also really good remotely because students, you don't have to share your screen necessarily. You can just have them go to this, and they will see your presentation right in front of them. So there's that, right? Tells you how to make an account. And then you start getting the interactive features of it. So here's the first slide. This is the student look. So I'm asking, hey, how's it going today? Let's do a check-in. And they can drag this and say where they're at, whatever it may be. And then you can see it on the teacher's side. If I open I can see responses. If I want to display everybody's response all at once, I could do that in a similar way as Desmos. And I can either show them all separate side by side. I can show them as a one big slide all at once, and I can scroll through them all. But what's really cool too is this overlay option, where if I had a bunch of students, I could just have all of their answers all in one spot, and I could see a bunch of purple lines in this case, and I could kind of see who's where, and I could just hover over that and see who answered that. Again, I wouldn't display that overall, but I could see that for myself on this dashboard piece. Okay. So, next piece. Here's an example again. So here's a drawing slide. This is what I see that I'm presenting to the students, but this is what the student sees, and it's interactive. They can change it on here. They can write text. They can make straight lines. But I want them, show how you would find it so they can show their work, and they can show their rise and run and mark that off. They could show that they're going, steps, whatever. They can show they go this way, and write their work that they're going. What is that? That's 7, 6. Can't read. Whereas this is a negative, and that's a negative if I'm going this way, anyways. All right, test my math skills on the spot here. So they can at least show their work of how they're getting there instead of just typing it in as you might on an iExcel or something, which is fine. iExcel, I got nothing wrong with it. I like some of it has to offer. I've used it myself. But this gives a good idea about, giving an opportunity for the students to show their thinking. Next piece. So again, just pointing out, hey, have them break down the concepts. Don't just have them solve a question about fractions. If you find 1/6 of a number, what does that mean is going to happen? Are you going to get bigger or smaller than your original? And then here it's the typing, so they would answer whatever it might be. They might say, and it might be a discussion. Is it a lot smaller or a little smaller? Maybe everybody answers C or D, and they give an explanation. And then you can see their answers on again, you can show responses, or you can have this yourself on a separate screen or separate device. You can see their answers in one spot, so you're not projecting it. And this is what I see, right? I type that in. This is what I see. I would see all of them listed here. Or again, I would see them as a grid instead of a list, whatever it may be. And we could see their answers, and I could star some and say, here, I want to display this one, and click on the ones I want to display. Or I could hide a response if I didn't want that one displayed as I go. And then this is also where I can leave feedback for them. So I can click this and see, and click that to say, here, here's some feedback about your answer, and then they would see it. Okay. And more. So, boom, I do that. And then on the student side, you can see down here, it shows them they have feedback. Right? And they can see it. They can say, I gotcha. Okay. I do wish you could reply back as a student, but that's not there yet. So anyways, here's more. So again, focusing on the student explaining themselves besides just solving. Drag the numbers to show which steps you would use to solve this equation. So on the student side, here's a 1 and a 2. So they drag this and they say, what's the first thing you would do? What's the second thing you would do? So, it's not a written description, but they do have to kind of show in a different way that they know what's going on. And I can get an idea through the whole class without reading a whole bunch of answers. I can get an idea of how they are by looking at this overlay, right? And again, I can hover over and see who answered that, and I can get a whole bunch of them to see which one's like, whoa, man, this one that said add to 16, and I can address that and leave them feedback. And then if it's in person in class, even better. I can go find them and talk to them about that. Okay. So again, similar to that, when solving for a variable in an equation, why is it necessary to do operation of both sides? Gets them a chance to explain themselves again, besides just solving. That's the shift, right? There it is again. Then, you know what? You can have them solve. Go for it. I want you to actually solve all this. After going through those steps, now I think you're ready. I want you to show me, and they can write it out, which is hard sometimes with a non-touch screen, but not impossible, right? Not completely impossible. But they can also use text here to show things. So that's valuable as well. So it does help with that. Erase all of that. All right. Text, just click on, and then get rid of if they need to. So yeah, explain themselves. Have questions that elicit those thinking. That's how you can draw out more of that online. And then this one again, an example, right? Instead of just asking them to figure it out right away, what are you figuring out? If they want to talk about, hey, they want to fill the box full of something and ship it, what is that doing? It's, whatever, finding area, perimeter, surface area, or volume. They have to explain that first, and I can get a sense of their line of thinking versus just saying, wow, you're way off, and then having to go back and dig into it. I can have them explain their thing along the way, so I can find that one checkpoint along the way before we get to the end and address that before it happens, right? It's like trying to fix some sort of symptom before it gets worse, and then you have to uncover the layers of what's causing stuff. You have to dig down and eliminate problems here or there that might be the symptom but not the cause. Whereas if you can find that ahead of time, you might have a better chance of helping them out, and then they can have that relief and confidence, right? It all comes back to that. Okay, so that's the overall idea of Pear Deck. Again, there's a little bit more to it. Feel free to check it out or ask about it. But that's how you can use Pear Deck to help out, finding student thinking with that digital tool there. All right, I'm going to exit out of this because I'm getting confused with too many windows open. So dashboard using Google Slides, and the Google Slide piece, again, if I wanted to on this account, it's an add-on. I can go to get add-ons, and then it would show up here for it, or eventually it does make it a separate menu item up here. And this is what it would look like in your Google Slides. I could make this Google Slide. I can, instead of for my notes, instead of having it like this, I can make it a Pear Deck instead, and I could click, all right, make this a text slide right now, and it would. I'll do it on a separate slide that I can just delete after. So right now I can click that and it will pair magically change that, and now this would be an interactive slide for them for whatever it is. They have a bunch of those options there. They have templates already. So beginning of lesson, if I want, a simple, here's instructions. What did you learn? Whatever I want to ask them. What did you wonder about today's topic? They have a bunch of those. End of lessons, exit ticket type pieces. They have that. They have some content specific setups that you can use. That's in there. You can, again, integrate Desmos slide. You can have a slide there where the side of it is a Desmos. Right here, actually, I had it in the next one. And on their screen, it's the Desmos graphing calculator that they can use right there on that Pear Deck. So they have a bunch on here to explore for various subjects, various grade levels, age levels, all of that. Okay, delete that so it doesn't have that messed up later on. And then to start a lesson, I can either have them log in with their Google accounts or not, so I can see their information. And then start the lesson. That's how I started this one. And then when I go to end it, I can name it. So demos already, and then I can share. I can share their responses, generate these takeaways with the premium membership. I can say, here's your responses. It makes it a Google Doc, and they can see their answers. So have it for later, kind of make a digital portfolio of sorts later on. Or I can have them open the reflect and review, which is similar to what that Desmos piece was, where I can see one student's stuff all at once in a nice big area. Right? I can see their answers like this and then leave them feedback like that in this one spot instead of having to click through on that dashboard like we saw over here. Right? Instead of having to click through and do it this way, I can do it all in one spot, which is honestly, this is pretty new. It organizes things pretty nicely now to do it this way. I like this way a lot. It goes quicker. It's easier than what it had before. And then that ends that session, and it saves it all on your Pear Deck account here. Okay, so the whole idea here again, shift the expectation of the students, shift their learning, what you're asking them for, have them explain themselves along the way. You can still get to that whole, what's the answer and to solve things and that skill. But honestly, explaining themselves, I think, is becoming a more prevalent part of math education than it is just solving. For more information on that, feel free, look up, concept-based learning in math. There's plenty of information out there. Go to Better Math Teaching Network. That's a network, kind of based around New England of math teachers that have dug into the studies of that. And there are a bunch of local educators across the states of New England that are part of that. Look at Joe Bowler's research. She's done a bunch of that, and Dan Meyer as well. They're kind of leading this charge, or one of the leaders, a couple of the leaders of this. So yeah, that's how you can use the digital tools to get more out of student thinking. That's how you can leverage this information to get more students explaining themselves and better confidence in themselves. I think. If you have questions or anything like that, feel free to reach out. Again, Rob Dominic at maine.gov. MLTI websites here as well. Feel free to ask or check in on that. Thank you. Hopefully you can use this and it's started your wheels turning for how it can be applicable for you in your classroom.